So to model the satellite orbiting the Earth, I set up a relationship with two equations at first. The first being this one, to determine what force the Earth would be exerting on the satellite due to gravity, with the masses and the radius between the two centers. And also using this equation, which gives us the net force given a mass, velocity, and radius that uniform circular motion will need to occur. So since the satellite will be orbiting in uniform circular motion, we can set these two equations equal to each other to determine the relationship. So we have the satellite starting off in just the x direction. So this will be the unit vector. We know the mass is 1,500 kilograms. We know the mass of the Earth, the constant, and again the mass of the satellite here. And the radius here, since we define Earth to be at the origin of the coordinate system in the model, the radius is just going to be the position vector from the origin to the satellite, which is just its coordinates, since the Earth again is at the center, which is what we want to measure from. So after doing some algebra, I determined this relationship first. But then, since it also needs to be in geosynchronous orbit, we need to figure out, given the velocity, how far it's going to travel in 24 hours. It needs to complete one circle in 24 hours, which is what the Earth rotates at. So this relationship determines this. So now we have two relationships. Can solve for the velocity of the satellite, which will be its perpendicular velocity initially, and this will be this number here. And we can also determine the distance that the satellite will need to be from the center of the Earth, which is this number here. So when we go to the model, I put in these parameters: the satellite starting position in the x, which is the distance from the center of the Earth, and the momentum needed for the velocity of the satellite to be this number here. So this time will give us one orbit, one rotation, one full rotation about the Earth. And when we run it, the red vector is the velocity, the red arrow, rather, represents the velocity of the satellite, and then the blue arrow represents the force from the Earth. And the force from the Earth is scaled up so you can see it, but it's about 1/10 of the velocity, meaning that the gravitational force is 335 newtons, which is the magnitude. So the arrow is going to be smaller than the velocity, so I scaled it up. And those are the answers to some of the questions. I put them in the code. And I believe I didn't show the hand calculation of the momentum, but it's right there, which is the mass of the satellite times this velocity. But that answer is right there. in momentum units. And that is my simulation. Thank you.